The Dynamic Learning Maps Alternate Assessment System is a new assessment designed to more validly measure what students with significant cognitive disabilities know and can do. This training on composing and decomposing shapes and area provides information to teachers of students with significant cognitive disabilities who will complete the alternate assessment. This training is one in a series of training videos that supports teachers of students with significant cognitive disabilities in their efforts to teach and assess. Sponsored by a grant from the U.S. Department of Education, Office of Special Education Programs, this training is part of the professional development efforts of the Dynamic Learning Maps Alternate Assessment Consortium. Spatial thinking or reasoning involves the location of movement of objects and ourselves. This movement can happen mentally or physically. According to the National Research Center, spatial thinking is not a single ability or process. Instead, it is comprised of a variety of concepts, tools, and processes. Spatial thinking plays a fundamental role in our lives. It impacts our everyday activities as we navigate in our school or community, locate objects or remember the location of those objects, and when we move our bodies through space. In this module, we are going to address just one aspect of spatial thinking, the aspect that addresses shapes and their relationship with each other. In the module on basic geometric shapes, the focus was on teaching students about shapes, but it didn't address shapes in conjunction with other shapes, as this module will. The big idea of this module is that smaller units can combine to form larger units, and larger units can be separated into smaller units. For example, a rectangle can be separated into 2 smaller squares, or into 4 triangles. This is not the first time we've encountered this idea. This same idea is found in the base 10 number system, where students combine smaller numbers like 4 and 5 to form the larger number of 9. And they separate a larger number as the sum of 2 smaller numbers, for example as 7 as 3 plus 4. In the same way that students learn about composing and decomposing numbers through exploration and guided practice, students need opportunities to explore how shapes fit together to form larger shapes, and how shapes can be taken apart to form other shapes, to learn about composing and decomposing shapes. It is best to begin by asking students to use familiar shapes to compose other shapes. For example, putting 2 triangles together to make a square, or using a square and a triangle to make a house. Students can explore decomposing shapes by covering part of a larger shape with a smaller shape and analyzing the remaining space. When I cover part of my square with a triangle, I can see another triangle in the empty space. As students gain competence in combining and composing shapes, they will build toward more complex pictures and designs. What begins as trial and error gradually becomes purposeful and systematic combinations of components. For example, a student might say or think, this triangle fits here because the corners match the puzzle. As students manipulate and explore shapes, they are also building understanding of fractions. You can support this understanding by offering guided practice with composing and decomposing and telling students things like, when you divide the rectangle in half, you get 2 squares. Here is 1/2, and here is the other half. You can learn more about fractions in the 2 modules, Fraction Part 1 and Fractions Part 2. Pause for Activity 1. Composing and decomposing shapes helps students develop an understanding of fractions, and it also helps students develop early understandings of the geometric concept of area. Area is the 2-dimensional space inside a region, and as students explore shapes that can be decomposed into smaller shapes, they are working with area. There are three concepts related to area that can be worked on while students are learning about shapes. First, students can learn that the area of a shape is determined by the outline of the shape. Second, they can learn that the area of a shape does not change when it is moved. Finally, students can learn that two shapes have the same area if they match or all the surfaces fit together. Students can also develop an understanding that the area of a shape can be partitioned into equal-sized shares. As you can see on your screen, one whole has been partitioned into equal-sized shares. By fourth grade, the essential elements expect that students will have had enough experience with shapes that they can begin counting unit squares to determine the area of the shape. A unit square is 1 unit of measure on all sides. That can be 1 inch, 1 centimeter, 1 mile, or whatever other measure of length is appropriate. But each unit is counted as 1. Then the area is determined by counting the number of units that will cover the shape. These shapes all have the same area of 9, but understanding that shapes with the same area may look different is a hard concept for students to grasp. An activity that will help them with this concept is to provide a set number of tiles and ask students to create different shapes with the tiles. The rules are that all of the tiles must be used and there can be no gaps or overlaps. As students make each shape, ask them to count the tiles to determine the area. Draw their attention to the fact that all of the shapes they created are composed of the same number of tiles, which means they have the same area. This links back to the concept presented earlier. The area of a shape does not change when it is moved. By 7th grade, the essential elements focus on determining the area of a rectangle using a formula for length times width, and confirm the result using tiling or partitioning into unit squares. The rectangle on your screen is 9 units long and 6 units wide, so we find the area by multiplying 9 times 6, which equals 54. Once students determine this, they then confirm the result using tiling. Students will lay the tiles with no gaps or overlaps, covering the shapes, and then count the total. Students learn to ask themselves, does the total number of tiles match the answer to our equation? In this case, yes it does. Pause for Activity 2. To sum up this presentation, the expectation is that students will recognize area as an attribute of two-dimensional regions. They will develop an understanding of the big idea that smaller units can combine to form larger units, and larger units can be separated into smaller units, and will use this understanding as they measure the area of shapes by finding the total number of same-sized units of area required to cover the shape without gaps or overlaps. Finally, students will understand that a rectangular array can be decomposed or partitioned into identical rows and columns. By decomposing rectangles into rectangular arrays of squares, students connect to multiplication and justify using multiplication to determine the area of the rectangle. Thank you for participating in the Composition and Decomposition of Shapes and Area module. For further information, please go to www.dynamiclearningmaps.org.